Hello everyone. This is a little bonus video for section 4.6, Newton's method. And yeah, this might be of interest if you are going into computer science, computer programming, anything that involves code programming really. So I wanted to show you an example of how Newton's method is readily coded up. Maybe not so much behind the scenes, but what you can see from a front view. So the little site I have here was actually made by my sister when she was in community college just a couple years ago. She's 22 now and she's a senior at University of the Pacific and she's majoring in electrical engineering and she's amazing and I'm super proud of her. So I wanted to show off the little website that she made because it's pretty cool. So yeah, this was one of her side projects when she was a community college student, and yeah, it runs a nice Newton's method. So I'm going to enter in just a interesting function here. That's the first thing you do. So I've set up a little seventh degree polynomial for us. Okay. So it'll convert it to nice mathematical notation there, x to the 7th plus 3x squared minus 5. And this is a root finding calculator. So this is going to find the root of that equation, which is nice because that's not something we would want to solve by hand to see where that function equals 0. So let's hit enter. And it provides us with the derivative of that function, because we know that's a big part of Newton's method, and also the graph of what we're looking at for the root there. So you can see on the little graph that the root of this equation is somewhere around x equals 1. So down here on the bottom where it says to guess an x value, I'm going to start with x equals 1. And then when I press enter, behind the scenes, this is going to run Newton's method with that being our first guess, and then this function and this derivative up top. So press enter. And you can actually see all the iterations that this is going through. So here's your x naught is 1, and then x1, x2 values. And we see we get convergence pretty quickly there. X4, x5, and x6, they're all the same values. So Newton's method has converged pretty quickly on this problem. So yeah, found the root around 1.07, and there we go. Now let's try another x value, like x equals 2, because we see that's ballpark pretty close as well. And turns out x equals 2. We'll also end up finding that root. Okay, it just took a little bit longer here. Notice how here's our x naught equals 2. The previous, when we said x naught equals 1, we got convergence in like 6 iterations or so there. Now we don't have convergence until x8 and x9 down here. So putting in 2 still worked. It just took a few more iterations, probably because we're a little farther away from the root there. Okay, now let's try one more thing. So let's go to the other side and guess x equals 0. And notice how it says that no root was found. Okay, so something's going on here. And if we zoom out a little bit, we can see exactly what. Okay, so when x equals 0, it turns out that the function has a horizontal tangent line. So remember, Newton's method is based off of this idea of tangent lines. You pick an x value and you make that first tangent line and you find where that tangent line's root is to get your next approximation. But when we have a horizontal tangent line here, that's not going to have a root. Okay, so there is no next iteration and no root was found because Newton's method isn't going to work that way. All right. So yeah, no root is found if you have a horizontal tangent line. It doesn't work out. But we could put in other x values like 5. Okay, takes quite a few iterations, but ultimately it gets there. We could go out further, but I think you guys get the idea. But yeah, if you're in the area of computer science, anything with programming, if you need to do a final project or something like that, you might want to consider doing a little Newton's method calculator, because like I said at the start of this section, Newton's method is a really nicely programmable method here for finding roots. So there you go. Hope you found that interesting.